Electrolysis is the process by which an electrolyte is decomposed by an electric current. The electrolyte is a liquid or molten substance in which the atoms are dissociated into ions, making it able to conduct electricity. An electric current is a flow of charged particles which includes electrons or ions. The electrolyte which is being decomposed has to be molten or in an aqueous solution. Substances that do not form ions in solution will not allow electricity to flow through them. These are non-electrolytes and include most organic substances. Electrolytes are of two types, strong and weak. Strong electrolytes are fully ionized in aqueous solutions, that is, they contain a large number of ions, and these include soluble ionic compounds and strong acids. Weak electrolytes are partially ionized in solution, that is, few ions are present, and these include weak acids and weak alkalis like ethanoic acid and aqueous ammonia. Sparingly soluble ionic compounds such as calcium hydroxide are also considered weak electrolytes. The apparatus involved in electrolysis is called an electrolytic cell. It contains a battery or power pack, a switch, conducting wires, two electrodes, and a container for the electrolyte. To start the process of electrolysis, two conductors are placed into the electrolyte. One, the cathode. This is the negative electrode and is connected to the negative terminal of the battery. It allows electrons to enter the electrolyte. The other conductor is called the anode. This is connected to the positive terminal of the battery. It allows electrons to leave the electrolyte. These electrodes may be made of metal or carbon. Okay, what exactly happens when we throw the switch? When the battery or power pack is switched on, electrons flow from the battery to the cathode. The positive ions in the electrolyte, the cations, move to the negative electrode or the cathode, where they undergo reduction. They gain electrons and become pure form of an element. When this happens, the cation is said to be discharged. The negative ion or the anions move to the positive electrode, which is also known as the anode, where oxidation occurs. They lose electrons and also form an element in its pure form. When this happens, the anion is said to be discharged. In some cases of electrolysis, more than one cation and anion migrate to the electrodes. The determination of which ion is discharged depends on 1. The position of the ion in what is called the electrochemical series. The electrochemical series is a list of metallic ions in order of their ease of reduction and non-metallic ions in order of ease of oxidation. The lower an ion is in the electrochemical series is the more likely it will be discharged in preference to an ion higher up. 2. The concentration of the ion. The greater the concentration of the ion, the more likely it is to be discharged. This applies especially to ions relatively close together in the electrochemical series, such as the halide ions, chloride, bromide, and iodide. 3. The nature of the electrode. Here, an electrode may become active rather than being inert and will dissolve to form ions. An example of this is the electrolysis of copper sulfate with copper electrodes. Now that we have looked at the general process of electrolysis, let's look at some specific examples. The first thing you must do is identify the ions that are present. In the case of molten sodium bromide, only two ions are present, sodium and bromide ions. At the cathode, sodium gains an electron and is reduced. At the anode, each bromine ion loses an electron and is oxidized. At the cathode, the sodium ion gains electrons, while at the anode, electrons are given up by the bromide ion. Since the sodium chloride is dissolved in water, the following ions are present: sodium, chloride, hydrogen, and hydroxide from the water. Both hydrogen and sodium ions migrate to the cathode. However, only hydrogen ions will be discharged initially. They are lower in the electrochemical series and require less energy. 2 moles of hydrogen ions gain 2 moles of electrons to give you 1 mole of hydrogen gas, and that is reduction. At the anode, both hydroxide and chloride ions migrate to the anodes. The hydroxide ions will be preferentially discharged since the chloride ions concentration is low. Moreover, hydroxide ions are lower in the electrochemical series and require less energy. The hydroxide and chloride ions are very close in the electrochemical series, and the hydroxide ions would only be discharged in very dilute solutions. 4 moles of hydroxide ions lose 4 moles of electrons to give 2 moles of water and 1 mole of oxygen gas. The ions present in the solution are copper 2+, hydrogen, sulfate, and hydroxide ions. At the cathode, both the copper 2+ and hydrogen ions will migrate to the cathode. Copper 2 will be discharged preferentially as it is lower in the electrochemical series and requires less energy. Copper 2+ gains 2 electrons to give copper in the solid state. Reduction has occurred. At the anode, both the sulfate and hydroxide ions migrate to the positive electrode. Hydroxide ions will be preferentially discharged as hydroxide is lower in the series and requires less energy for oxidation. Since the hydrogen and sulfate ions are left behind, the electrolyte becomes more acidic and the solution loses the blue color since the copper 2+ ions are discharged. The copper 2+ ions are blue in aqueous solution. Ions present are copper 2+, sulfate, hydrogen, and hydroxide. In this example, the copper anode becomes active and ionizes to form copper ions. Copper loses 2 moles of electrons to form 1 mole of copper 2+ ions. Oxidation has occurred. The copper 2+ ions migrate to the cathode and are discharged, forming a coating of copper metal on the negative electrode. The concentration of the electrolyte does not change during the process as the quantity of copper 2+ ions entering the solution at the anode is exactly equal to the quantity of copper 2+ ions leaving the solution at the cathode for a given quantity of electricity. The ions present are hydrogen, chloride, and hydroxide. Both the chloride and hydroxide ions migrate to the anode. The chloride ions will be preferentially discharged as they exist in a higher concentration. 2 moles of chloride ions lose 2 moles of electrons to give 1 mole of chlorine gas. At the cathode, only hydrogen ions migrate to the cathode and will be discharged to form the product hydrogen gas. 2 moles of hydrogen ions gain 2 moles of electrons to form 1 mole of hydrogen gas.